Hey, Mr. Riley here with the first lesson of their next unit here, which is going to be on proportional relationships. And we're going to start by looking at the first two topics here in the book on ratios and unit rates. Proportional relationships have lots of use, and we'll be working with lots of ratios and rates through this entire unit. So first, ratio. Ratio is when you have two measurements, two quantities that are compared by division. So they can be written three different ways in words. You say, 3 to 9 with a colon like that, and you still say 3 to 9. Or as a fraction or division problem, and you say 3 to 9. Okay, so the order of the numbers is important, right? The first one is going to be the top of the division, the top of the fraction, and the second number at the bottom. All right, so what do you have to be able to do? Well, you should be able to simplify ratios, which is basically simplifying fractions. So the example here, 12 baskets in 18 attempts, express that as a fraction in simplest form and explain its meaning. Okay, well, that means really just re-saying what it said. So write the ratio as a fraction and then simplify the fraction. So simplifying fractions, you go back to this, is done by dividing the numerator and denominator by the greatest common factor, the largest number that goes into both of them evenly. Now, you can try to figure out what that largest common factor is. There are methods for doing that. I personally do not ever use those methods. Instead, I choose to go with divisibility rules. So there are rules that will tell you whether or not these two numbers are divisible by 2 or 3 or 5, some basic numbers that you can check. And let's review what those divisibility rules are right now. So you know that both numbers in the fraction are divisible by 2 if the last digit is even. 0, 2, 4, 6, 8. Then both the top and the bottom are divisible by 2. We'll skip 3 because that's the one that people don't remember. And 4, 6, 7, 8, 9. I don't ever use any of those. You kind of can if you're really on top of those things. I've never even don't know what this 7 one is. But anyway, 5 and 10, those are certainly more common and used all the time. Both a number is divisible by 5 if it ends in a 5 or a 0. A number is divisible by 10 if it ends in a 0. And how can you tell if a number is divisible by 3? And this is a good trick because lots of numbers are divisible by 3. It's a little trick to determine if a number is divisible by 3. You add up all of the digits, the sum of the digits, and if that number is divisible by 3, then the large number is divisible by 3. So those are your divisibility rules that you can use to simplify fractions. So here, this was 12 over 18. Those are both even, so you could divide them both by 2 and get 6 over 9. Or if they're both small numbers like this and you use your times tables, look, pretty easy to tell they're both divisible by 6, and that you get 2 over 3. These are equivalent fractions, right? They're the same exact number. Just this one is in simplest form. All right, so the example here says the bottlenose dolphin lives to be 30 years old, and a mouse lives 3 years. Quick life for the mouse. So what is the ratio of the lifespan of the bottlenose dolphin to the lifespan of the mouse? So be careful in the wording. What's it asking? It's asking for dolphin years to mouse years. So that's 30 to 3. 30 divided by 3. And that, of course, simplifies to 10 to 1. Then what does it mean? Well, it's sort of just like rewriting the thing. But, well, in this one, it's not really because it's in a table. So what does that mean? That means for every 10 years that a dolphin lives, a mouse lives, the mouse expectancy is 1. So the dolphin lives 10 years to every 1 year for the mouse. Don't worry too much about the explain questions here on these problems in the book. All right, example 2. 10 out of every 30 Americans owns a portable MP3 player. Express this ratio as a fraction in simplest form and explain its meaning. Okay, I doubt that I know that this is not true because I looked it up. So this is a pretty old book. The publishing of this book, it's probably about a 2013 statistic here that 10 out of 30 or 1 in 3 Americans owns a portable MP3 player. I mean, some people still do, I suppose, but most people now use a smartphone to do the same thing that their iPod used to do. Okay, let's take a look at the statistics now. Just look this up here. That from 2013 to 2018, the change in MP3 players that people owned. Okay, the darker one here is how many people purchased headphones. Okay, which is how you get your music from your phone, right? So the ratio here from 2018 to 2013 is about 75 to 300. It's about $75 billion spent. $0.75 billion spent in 2018 and almost $3 billion spent in 2013 on MP3 players. So about 75 to 300. Let's simplify this ratio. All right, so these are two pretty big numbers. What are 75 and 300 divisible by? What's the largest number they're divisible by? You might get lucky sort of and think about it if you're good at some multiples of 25. But you could go through all your divisibility rules. Is it divisible by 2? No, because the 5's not even. It is divisible by 5. So you could do that. Divide both of these by 5 and get 15 over 60. Okay, which is still, these are still both divisible by 5. Okay, which means that if it was, they are both divisible by 5, that means it was actually the original number was divisible by 25. Okay, so we could do that. And what's 75 divided by 25? Ooh, that's terrible. 75 divided by 25 is 3. And 300 divided by 25, there's 4 25s in every 100. So that's 12. 3 over 12, well, that's can be simplified again because those are both divisible by 3, right? Which means that the original number was actually divisible by 75, which you might have gotten right off the bat. 75 goes evenly into 300 4 times. So you can divide by 3 there and get 25 over 100. You divided both of these by 3 because 7 plus 5 equals 12, divisible by 3. And the final answer, though, if you divide them both by 75, is 1 to 4. So your final answer here would be 1 to 4, which means that 1/4 of the amount of money spent now or in 2018 on MP3 players as was spent in 2013. Okay, so MP3 sales drastically reduced. Okay, so here's I got it in the book here. 15 out of 100 campsites at the campground are reserved for campers with pets. Express this ratio as a fraction in simplest form and explain its meaning. 15 out of 100 simplifies to 3/20, 3 to 20. What does that mean? It means out of every 20 campsites, 3 of them can have pets. For every 20 campsites, there are 3 that have pets allowed. All right, be careful when the one thing that trips people up quite a bit here in doing ratios is that sometimes the numbers you're given in the problem are not the numbers that you are going to put in your ratio, because every ratio, really every simple ratio, has 3 numbers, the 2 parts, okay, and then the total number of things. And sometimes they ask for the ratio of part to part, and sometimes they ask for the ratio of 1 part to the whole. Sometimes you're given both parts, sometimes you're given a part and a whole. You can calculate all of the numbers, obviously, by just doing simple subtraction or addition. Okay, so here's what I'm talking about. Here's an example. The Patriots have won 4 games and lost 6. Today we could change this to 5 games, but the Patriots won 4 games and lost 6. What is the ratio of games won to games played in simplest form? Okay, so you got to read this carefully. They won 4 games, but how many games did they play? They did not play 6 games. That's how many they lost. So you have to add these 2 things up to get the total number of games, which is 10. So they've won 4 out of 10, which simplifies to 2 out of 5. Both divisible by 2. Okay, so read carefully with what the question is asking. If it asked what the ratio is of games won to games lost, then it would be 4 to 6. Okay, so here's another example like that one. In the batting cage, Mac got 10 hits out of 16 pitches. What is the ratio of hits to misses? The ratio of hits to misses. So the three numbers that you have to watch out for here, the number of hits, they gave you that. That was 10. The number of pitches, they gave you that. That was 16. Okay, but we're looking for the ratio of hits to misses. How many misses were there? Well, if there were 10 hits out of 16 pitches, that means that there were 6 misses. So the ratio that the question is asking for is hits to misses, which is 10 to 6, which simplifies both of these divisible by 2, simplifies to 5 to 3. 5 hits for every 3 misses. Now, the next thing that will mess people up with ratios is when the units are not the same. So ratios that get simplified like this have to have the same units in the two numbers. Okay, so when it's a measurement like length or volume or time, sometimes the measurements are in different units, and so you have to make them the same before you do the simplifying. For example, 8 ounces to 3 pounds. What is the ratio of these two weights, 8 ounces to 3 pounds? Well, you'd have to make them both into ounces or both into pounds. It's usually easier to make them into the smaller one because you don't have to divide and get decimals or fractions then. So 3 pounds, well, how many ounces is that? Oh, these are one of the equivalent measurements that you're kind of supposed to know. Okay, there are 16 ounces in a pound. 16 ounces in a pound. So that means 3 pounds is 3 times 16, or 48 ounces. So now I have ounces to ounces. 8 ounces to 48 ounces simplifies. They're both divisible by 8. Simplifies to 1 ounce to 6 ounces. And because the units are the same at the top and the bottom of this ratio, right, we do not need any units. The ratio of these weights is always 1 to 6, no matter what the units are. It would be 1 pound to 6 pounds. It would be 1 gram to 6 grams, 1 ounce to 6 ounces. The ratio of the weights is 1 to 6, no units. So some of these problems, of course, require you to know the equivalent measurements. The back cover of your textbook is a list of them. Obviously, you can Google these also. There are some that you should just know that you shouldn't have to look up, right? The basic metric conversions of a kilo means 1,000, right? So there's 1,000 kilometers, 1,000 meters in 1 kilometer, 1,000 grams in a kilogram, 1,000 liters in a kiloliter. Centi is 1/100th, 100 centimeters in a meter, and milli is 1/1000th. There's 1,000 milligrams in a gram, 1,000 milliliters in a liter, etc. That's the metric system ones. And then customary units, 12 inches in a foot, 3 feet in a yard, 2 cups is a pint, 2 pints is a quart, 16 ounces in a pound, times, seconds, minutes, hours, days, weeks, years, all ones that you should know. And if you don't know them, you can look them up. Conversions from metric to customary systems, these are the ones that are hard to remember. You really don't need to know those. You can look them up, or again, use Google to do those conversions. All right, so here's the example problem for this one. I got it. What is the ratio of 15 inches to 1 foot as a fraction in simplest form? So it's not 15 to 1. That is not the ratio of the lengths. It's 15 inches to 1 foot, which is 12 inches. So you have to convert that. So you have inches to inches. It's 15 inches to 12 inches. And this fraction simplifies. 15 and 12 both divisible by 3 to get 5 to 4. 5 to 4, no units. No units in this answer because it doesn't matter if it's inches or feet or meters. The ratio of the lengths is always 5 to 4. All right, here's a handful of guided practice problems for you to do here about simplifying ratios. Pretty simple stuff. So we'll give you a minute here. You can pause the video, knock these problems out, and we'll check your answers. Number 1. Now, boys and girls are not the same, but it is people, so you're still not going to have units. 12/16 simplifies to 3/4. 24 out of 60 light bulbs Those are both divisible by 12. That's 2/5. 36 DVDs out of 84. Hopefully you recognize 84 is 12 times 7. So these are both divisible by 12, 3/7. And 50 tiles to 25 tiles. That seems like a ratio of 2 to 1. Mr. Blackwell's class, 15 of 24 students play sports. Express this ratio as a fraction in simplest form and explain it. 15 out of 24, these are both divisible by 3. And you get 5/8. What that means is, out of every 8 students, 5 of them play sports. 5 students play sports out of every 8 students. And now some with unit conversions, express the ratio as a fraction in simplest form. So first you should write the fraction so that the units are the same, and then simplify that fraction. 3 pints to 4 quarts. A quart is 2 pints, so that's 3 pints to 8 quart. 3 pints is to 8 pints, and that's 3 to 8. Number 7, 2 pounds to 6 ounces. So 2 pounds to 6 ounces. That's 32 ounces to 6 ounces because a pound is 16 ounces. And 32 and 6 are both divisible by, 32 is not divisible by 3, so divisible by 2. So that's 16 over 3. 9 inches to 1 yard. So you might not get inches to or yards to inches. But 1 yard is 3 feet and 1 foot is 12 inches. So 1 yard is the same as 36 inches. So this is 9 to 36, and that's 1 to 4. And the last one, 6 gallons to 3 quarts. How many quarts are in 6 gallons? There are 4 quarts in each gallon. So that is 24 quarts to 3 quarts. And 24 and 3 both divisible by 3, 8 to 1. A ratio of 8 to 1, whatever the volume units are. All right, so that is simplifying ratios. And that's the first lesson here from this unit. We will now move on to unit rates. All right, so moving on to topic number 2 here, which is working with unit rates. A rate is a specific type of ratio. It is a ratio where the two quantities have different types of units. They are not both lengths or both times or both volumes, but different units, somethings per something, okay, or somethings per whatsits, right, because they're different. So, so that is a rate, and you must have the units in there when you are expressing rates because the units are different. So this person types maybe 60 characters in 30 seconds. That is a rate, 60 characters per 30 seconds. But almost always, we express rates as a unit rate. So instead of saying per 30 seconds, here we want to say how many characters are typed per 1 second. And so to calculate a unit rate, you divide the numerator divided by the denominator. So 60 divided by 30 will give you the unit rate. Because when you divide, you're actually dividing the top and the bottom of this by 30. Okay, and the bottom becomes a 1. So that's then 2 characters per 1 second, or 2 characters per second. We never say the 1 really, like miles per hour or miles per gallon or words per minute. Okay, so those are unit rates, and unit rates are very, very important and very useful in the real world, okay, especially for comparing things. So expressing a rate as a unit rate requires you to do a division. That's all it is divide the whatever it's somethings per whatsits. You divide the number of somethings divided by the number of whatsits, and you get your answer. Okay, typically you'll get decimals that go on forever, or at least have many decimal places here. So you will typically have rounding instructions for these problems. If you don't have rounding instructions, then use a reasonable amount of decimal places. Okay, so $11 for 4 boxes of cereal. How much is it for 1 box of cereal? 11 divided by 4 is 2.75. Money problems always rounded to the nearest cent, unless you need to go further than that, which we'll talk about later. So this cereal is $2.75 per box. You don't say per 1 box. Okay, and you can write your answer with with the word per, or you can use the slash for per. So 270, and you have to have both units in there, dollars per box. 400 miles on 14 gallons of gasoline. So divide 400 divided by 14, you get 28.6, probably 0.6 repeating. No, maybe not. I don't know what you get in your calculator there. Maybe it's exactly that because it doesn't tell you. But rounded to the nearest tenth, 28.6 miles per gallon. And there are some times like this one where you can use if it is a universally accepted or generally accepted abbreviation, like miles per gallon is very frequently abbreviated MPG. Okay, like when you're talking about what kind of gas efficiency a car has. So MPG, MPH for miles per hour. Sometimes you can use that. You can't always use this. Okay, really only if it's an acceptable abbreviation can you do this, use the 3-letter abbreviation like this one. All right, so here's a couple quick got-its on this. $18.50 for 5 pounds of something, whatever it was you were buying. $18.50 divided by 5 comes out to 3.7. So again, because it's money, that's 3.70 or $3.70 per pound. Again, you can use a slash. You can use LB for pounds. You could write out pounds if you wanted to. You can use the word per. 100 meters in 14 seconds. 100 divided by 14 is 7.14285, blah, 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 right? A decimal that goes on well past the tenths, which was your instructions earlier. So rounding this to the nearest tenth, 7.1 miles per second, meters per second, meters per second. Single M is meters, MI for miles. You must have both units when you write a rate. If you do not write your units, you will lose points. All right, so comparing unit rates is where this really is useful in the real world. Like anytime you are shopping for things, because they come in different size packages or different amounts at different prices, it's hard to know which one is really the best price for them, which one gives you the most for your money. So here's an example here. An online music store sells 15 songs for $12, and another one sells 10 songs for $9. Well, which one is cheaper? Well, the $9 one isn't cheaper per song because it's a different number of songs. That's why you can only do this by comparing unit rates. It's always dollars per whatever when you are doing prices. So it's always the dollar amount divided by the number of units, in this case, the number of songs. So 12 divided by 15 is 0.8 or 80 cents per song. We don't say $0.8. You write it like this and say 80 cents. So the first store is 80 cents per song. The second one, $9 for 10 songs, is 90 cents per song. 9 divided by 10 is 0.9. And so the first store is cheaper. Each song there is only 80 cents compared with the second store where each song is 90 cents. Usually they'll give you more identifying things for the two pieces instead of first store and second store. You should label your work always with which one is which, and then make sure to answer the question, which one has the better price. Now they do talk in the little yellow sticky here about you can also use least common multiples. Sometimes these are so easy to get a common number of things by multiplying to get this common number of items and see what the prices are. Like 15 songs for $12 means 30 songs is $24. And if 10 songs is $9, well, 30 songs at this store will be 9 times 3 or $27. So you could, doing that instead of you getting a unit rate, you could use that method to figure out which store is cheaper. Also, you'd have to show that work also, though, when it says to explain or justify how you got your answer, you need to show each of the individual costs for the same amount of units. So a unit rate or the same price for the same number of items so that you can compare them. All right, so here's 1A. One store sells 2 different sizes of the same brand of sunscreen, 8 ounces for $5.76 or 12 ounces for $8.88. Which one is a better buy per ounce? So 576 for 8 ounces is how much per ounce? 0.72 or 72 cents per ounce. OZ is the abbreviation for ounces. The other one, the larger bottle, is $8.88 for 12 ounces. 8.88 divided by 12 comes out to 0.74 or 74 cents per ounce. So which one has the better unit price? In this example, it is the 8-ounce bottle. So the 8-ounce bottle has the better unit price. This is not normally how it works, right? Normally, the larger the amount of stuff you buy, the bigger the package, the cheaper the unit price. Okay, otherwise, why would people buy the bigger package if it's cheaper to just buy the smaller package? And so it's not typically this way. It's normally the other way around. Sometimes when things are on sale, this is when you use unit prices to figure out which one is really the better buy. So, and then of course, the other consideration is how much of the stuff do you need? If you don't need 12 ounces, then you don't buy 12 ounces because you're going to waste your money, even though the unit price might be cheaper. That's why in this case, you don't have that question, because the smaller bottle is the cheaper unit price. Okay. Always dollars per whatever it is that the things are being sold by the pound, by the foot, by the ounce, by the item. One last thing that unit rates are very useful for is that once you find a unit rate, then you can calculate how many things are going to happen in, for a different number of units. So if they tell you a ratio or a rate of certain thing, here in this case, 34 breaths in 4 hours for a dolphin. It's a long time to be counting dolphin breaths, but maybe somebody did that. So the dolphin takes 34 breaths in 4 hours. How many breaths is it going to take in 7 hours? Okay, and to do this, you calculate the unit rate, the number of breaths per 1 hour, by dividing 34 divided by 4. And you get 8.5 breaths per hour. If it's 8.5 breaths per hour, then how many would be in 7 hours? Now you're going to multiply 7 times 8.5. The hours will cancel each other out there, and you get 59.5 breaths. So the bottlenose dolphin takes about 59.5 breaths in 7 hours. Kind of silly to use 0.5 breaths there. I would round that to about 60 breaths. But then again, why is anyone counting the number of breaths that a dolphin takes in 7 hours? There are much better real-world problems than these. Okay, here's one if you're working at the bakery. So a bakery makes 195 donuts in 3 hours. Okay, well, at this rate, how many donuts will they be able to make in 8 hours? Okay, this is an important thing for running a business. How much can you produce at a certain rate, however fast you're making the things? So first, find the unit rate, 195 donuts in 3 hours. That's 195 divided by 3 is 65 donuts per hour. A little bit more than 1 donut per minute. Okay, and so that's for 1 hour. Then in 8 hours, you multiply this number by 8, 65 times 8, and you get about 520 donuts in 8 hours. Okay, so when you do these problems, make sure to show the work that you put in your calculator. Just this simple division or this multiplication, you need to show these steps. Because if you put wrong numbers in or put the numbers in the wrong order, or you mess up your calculator, without this, then I wouldn't be able to tell what you were doing. And you also couldn't tell if you know where your mistake is. Okay, so that step is a required step of work. Okay, round your answers as directed. Okay, if it tells you to round to the nearest tenth or as appropriate, a lot of times you don't have to round at all like these. Okay, and always make sure you have somethings per something in your answer. Donuts per hour in a unit rate. Okay, or you could have just said 500 donuts for this answer, because the question was how many can it make in 8 hours? But there must be a word there in your answer to all these real world problems. All right, so some problems here on the guided practice. Again, you pause the video, work these out quickly in your calculator, writing down what divisions or multiplications you are doing, and then we'll go over the answers. $120 for 5 days is $24 a day. 275 miles on 14 gallons of gas is 19.6 miles per gallon, MPG, a common abbreviation for miles per gallon. 338 points in 16 games. 338 divided by 16 is 21.1 points per game. Again, these decimals, because this is an average, right? So it doesn't, not that you would say, oh, you can't score 0.1 points in a game. That's true, but this is an average. Okay, so that's why rounding still makes sense and having decimals in an answer like this. Number 4, $19.49 for 6 pounds of something. Not sure what that is, but the price per pound is $3.25. Number 5, 17 gallons in 4 minutes. You're draining something or filling it. Hopefully not drinking 17 gallons of anything in 4 minutes. 4.25. Now, it says, I know it says to round to the nearest tenth, but if it comes out to a 0.25 or 0.75, a lot of times it bothers me to round this to the nearest tenth. Okay, of course, round it to the nearest tenth, the answer would be 4.3 gallons per minute. But 0.25, 0.75, those are hundredths places that, in my opinion, it's better to say 0.25 than 0.3 because you should know that that's a quarter, 4.25 gallons per minute. I wouldn't take off points if you did either one. Obviously, if you follow the instructions, it's 4.3. So, and the last one here, 180 feet in 19 seconds. 180 divided by 19 is 9.5 feet per second. FPS is, in physics and speed things, a common abbreviation, FPS. High-speed things like airplanes and stuff like that. All right, got a couple more here. Okay, this one's a good one. Which peanut package is the cheapest unit price? The Barrel, Mr. Nut, or Chips? Okay, so when you do the calculations for comparing things like this, you should label each one. You could abbreviate these if you wanted to, but Barrel is $3.39 for 10 ounces. $3.39 for 10 ounces is how much per ounce? 0.339 or 33.9 cents per ounce. Oh, why did I carry this to the third decimal place? Depending on how close together these are, sometimes you might need to go past the cents. Okay, you really don't know on the first one whether you're going to have to do. You really don't know until you do all three of them. So typically, I will carry an extra digit just in case. If this one comes out to 0.336, right, then they would end up being the same if you rounded to the nearest whole cent, but they're really not the same because in the thousandths place here, there would be a difference. So it's just a good idea if the numbers are small like this and just numbers of cents to carry 3 decimal places. Mr. Nut, 454 divided by 14 is 0.324, 32.4 cents per ounce. And Chips, $6.26 for 18 ounces is 0.348. So they're close. If you rounded them, you'd get 34. See, if you rounded this one, 34, 35, and 32. Okay, so obviously Mr. Nut here is the cheaper unit price. Make sure you write that answer. Mr. Nut is the best buy. Sometimes it'll ask you by how much, and you'd have to subtract it from the more expensive price. Okay, so this is a good real world problem. This is stuff people do all the time when they go shopping. You are choosing which packaging to buy, which quantity of things to buy, because you can compare to see which one is giving you the better price. The final question here, I believe, is Aisha drove 170 miles in 2.5 hours, 2.5 hours. At that rate, okay, how far will she drive in 4 hours? Okay, 170 miles, 2.5 hours is what speed? Okay, that's 170 divided by 2.5. 68 miles per hour. MPH certainly acceptable for miles per hour. So she's driving pretty quick here, Aisha, a little bit over the speed limit. Well, if she's driving 68 miles per hour, how far will she drive in 4 hours? Multiply, get an answer of, note what your final answer is. Make sure it has units. Units here is miles, not miles per hour, because this is how far she drives in 4 hours. All right, so simplifying ratios and calculating unit rates. Ratios have to have matching units. Simplify the fractions, and you do not have any units when in your answer when the units are the same. Unit rates always have different units. Okay, so you're going to have a slash or a per, and both of the units must be listed in your answer. Always show what you put in your calculator, your divisions, almost always divisions, sometimes, depending on what kind of problem it is, some multiplication. Round as directed or as appropriate for the problem, and always include your units in the final answer. And so that's the first two topics here of this, which will set us up to use these things for the rest of the unit.